Good morning. This is section 6.1, Angles and Their Measure. It is the first section in chapter 6, where we start trigonometry. And what we're going to learn here over the next 3 lessons is describing angles, using our familiar degree measure to measure angles, and then we're going to look at something new, a different way to measure angles in radian measure. And we'll learn how to convert back and forth between the two, degrees and radians, and we can use these ideas to solve and model real-life problems. A lot of this is going to be a review from previous math classes, especially geometry, and we will start throwing in some new stuff. Just the basics of what is an angle. You know, an angle has a vertex and 2 sides. In this class, where the angle starts is our initial side, and then the angle opens up, and we end at the terminal side. Connecting both the initial and terminal sides is the vertex. Now in this class in trigonometry, when we orient our angle, we are always going to put it in the xy plane here, with the initial side on the positive x-axis. Our angle will open up until we hit our terminal side. We open up our angles counterclockwise for positive degrees. If we do open it clockwise, that would be negative degrees. More on that later. And here it is right here. If we open up our angle from the initial to terminal side counterclockwise, it will be measured as a positive angle. If we open in the other direction, clockwise, it will be measured as a negative angle. 2 angles that have the same initial and terminal sides are called coterminal angles. The big part there is they have the same initial and terminal sides. If we look up here in the figure, we have this angle right here, alpha. As we open it up in the counterclockwise direction, it has the initial side here on the positive x-axis, and the terminal side is here in quadrant 3. We could also look at another angle, beta, opening in the clockwise direction, or a negative measured angle. It has the same initial side. It has the same terminal side. Alpha and beta are coterminal angles. We could also look at it as just another revolution around the xy plane. Here we start at positive x-axis, our initial side. We open up here to this terminal side. That is our angle alpha. Let's say roughly, maybe that's 50-degree angle. Another coterminal angle, coterminal, would be to, start opening up the angle and not stop right there, but do another lap around the xy plane. This angle here is a 50-degree angle. We all know that a circle contains 360 degrees, so what we did was open up our 50-degree angle and then do another lap around the circle. So if we add another 360 to it, we would get 410 degrees. The 50-degree angle and the one with the extra revolution, the 410-degree angle, are coterminal angles. Now here, I said previously, we have 360 degrees in a circle. If we start chopping up our xy plane up into degrees, we're going to have different angle measures. Anywhere between 0 and 90 degrees. Here's a right angle in our coordinate plane. Any angle between 0 and 90 is going to fall in quadrant 1. Over here we have another right angle. So any angle that falls between the 90 degrees and a full 180 degrees is going to be in quadrant 2. Picking up from there, our next chunk in the xy plane are all the angles between 180 degrees and 270 degrees. And finally, quadrant 4, any angle that falls between 270 degrees and 360 degrees will fall in quadrant 4. And here on the left, those are chopped up into smaller increments. Here we're looking at 90 degrees right angles. Now here we're taking each 90-degree quadrant and chopping it up. The most common angles you'll see in this class are 30 degrees, 45 degrees, 60 degrees. And then we have our 90, and if we reflect all of those into the next quadrant, 90 plus 30 is 120, 90 plus 45 is 135, 90 plus 60 is 150, and all the way around our circle. A little throwback to geometry here. We should all know this. An acute angle. What's an acute angle? Any angle between 0 and 90. Here we have a right angle. A right angle is exactly equal to 90 degrees, or now we're thinking about a circle, this would be a quarter revolution. Obtuse angles are any angles between 90 and 180. A straight angle, or a half revolution, is exactly equal to 180 degrees. And we have our full revolution. An angle that opens all the way around would be a full 360 degrees. All right, here's a little practice sketching and finding coterminal angles. Here, if we look at letter A, positive angle 390 degrees. So if I start here on my initial side and I open up a full revolution, that is 360 degrees, but we want to go 390. So I'm going to open that up another 30 degrees. So we started on our initial, we did a full revolution of 360 plus this extra little 30-degree chunk. So we have our 390 degree angle. I've sketched it here, and we know for sure it does fall in quadrant 1. Now to find a coterminal angle. I've actually already found one. You know, our positive coterminal angle is take 390, and since it's bigger than 360, we can just subtract a full revolution and get 30 degrees. 30 degrees is coterminal with our original 390. That's a positive coterminal. Let's find a negative coterminal angle also. Negative. You know, I want to start at my same initial side, but I want to go in the opposite direction, clockwise, and end at the same terminal side. Well, if this is a 30-degree slice of the circle, and our negative coterminal angle is a full revolution minus this little piece, we can simply go 360 minus the given 30-degree angle is a 330-degree angle, and it's negative since we opened in the clockwise direction. So negative 330 and positive 390 are coterminal angles. Oops. Let's look at letter B. Here's 0, 90, 180, 270. This angle now is positive 135 degrees. Well, if I start to open my angle, here's 90. If I go to 180, I've gone too far. So we're somewhere here in the second quadrant, 135 degrees. So that's our sketch. Now let's find two coterminal angles. Well, since I was given a positive angle, the positive coterminal will be the easiest to find. Just add another revolution around the circle. 135 plus 360 is 495. So here for our positive coterminal, I've opened up to the same 135 degrees, and then I just did another revolution around. 135 plus the 360 is 495 degrees. Now let's find our negative coterminal. We're going to start here at the same initial side, end here at the same terminal side, and we know that our positive angle was 135. There's only 360 degrees to go around. If I could look at this two ways. I could say 360, a full circle, minus the 135 that was given is going to give us 225 degrees. 225 degrees, and we just want to remember that that is a negative angle, negative 225. Or we could sort of just reverse that. My given angle was 135. I'm going to subtract a full revolution of 360, and that will give me the negative 225. For part C, the only difference now is they're giving us a negative angle to begin with. So we're starting here at 0, 90, 180, 270. And this angle is negative 120. So starting at the initial side, here would be a negative 90 degree angle. If I go another 90 degrees to negative 180, I've gone too far, so I want to back up, and I will be somewhere here in the third quadrant, negative 120. Since I was given a negative angle, the negative coterminal will be the easiest to find. I'm just going to subtract another 360. Negative 120 minus 360, add the opposite, and we get negative 480. Negative 480 degrees is coterminal with negative 120. It's just another lap around the XY plane. Now let's look for the positive coterminal angle. Again, here is our XY plane. There's a 360 degree circle in here. This angle has taken up 120 of those full 360. So if I go in the positive direction, I just got to think about the full circle, 360, minus the 120 that was already used, and I get 240. So this angle opening up here is a positive 240 degrees, which is coterminal with our negative 120. Something else you should remember from geometry are complementary and supplementary angles. Two angles, alpha and beta, with their sum is 90 degrees. Two positive angles, alpha and beta, are complements if their sum is 90. So if two angles add up to 90, they're complements. Two positive angles are supplements if their sum is 180. You know, it says see figure 611. Well, here is a right angle. We know a right angle is 90 degrees. If these two angles together form that right angle, they are complements. Their sum is 90. Here we have a straight angle, a half revolution. Here's angle alpha, and here's angle beta. If we put the angles together, they do add up to 180 degrees, so these two angles are supplements. So here for a little practice, example 2, complements and supplements, if possible, find the complement and supplement of first 72 degrees, and then next 148 degrees. So for part A, you know, the complement is just 90 degrees minus the given angle. 90 minus the given 72 is 18 degrees. 18 and 72 are complements. For supplements, it's 180 degrees minus the given angle. 180 minus the given 72 is 108 degrees. 108 and 72 are supplements. And part B. Part B is the given angle is 148 degrees. So if we try to find the complement, 90 degrees minus the given angle gives us a negative answer. And we don't want a negative answer, because back here in our definition, two positive angles. The angles have to be positive to be complements and supplements. Here, if we get a negative answer, or if we look at our angle, and our given angle is bigger than the 90 degrees that complements add up to, there is no complement. Not possible. Not possible. Or you could say no complement. Or DNE. That does not exist. Our given angle again is 148. We should be able to find the supplement. The supplement is 180 minus our given angle. 180 minus 148 is 32 degrees. 32 degrees and 148 are supplements. And the last thing we're going to cover today is converting between degrees and minutes and seconds. In your notes, we have our first angle here is 85 degrees, 18 minutes, 30 seconds. Much like time, angles can be broken further down from degrees into minutes, that one little tick mark, and seconds, two little tick marks. Now if you have your calculator, you'll see above, up here in the corner, we have our second function key. Down here in the other corner of the calculator, I forget what buttons they are, I think it's equals and maybe plus. If you look above those buttons written in yellow, you'll see two things. The one we're interested in for this example is we are converting, ooh, I got this backwards, my bad. The first thing we are going to do here, I got this sort of backwards, we're going to convert angles that are given in degrees and minutes and seconds back into decimals. So my angle was right. Here I had 85 degrees, 18 minutes, 30 seconds. And the button we're looking for on the calculator, above one of the lower right-hand buttons, you will see DMS, degrees, minutes, seconds, and then a little sort of triangle or arrow, and then a DD. This means convert degrees and minutes and seconds into decimal degrees. So when we punch this in the calculator, we want to insert a decimal point right here after the degrees. Simply punch in 85.1830, second function, and then do the conversion, DMS to DD. That should turn out to be 85.308 as a decimal. The next example in your notes is 330 degrees, 25 seconds. Now be careful when you're punching this in the calculator. In the previous we had degrees and then minutes and then seconds. Here we have degrees and seconds, but there are no minutes. The calculator does not account for that, so we want to think 0, 0 minutes. When we punch this in the calculator, we want 330.00 minutes, 25 seconds. And then do your second function and the conversion key, DMS to DD. This gives us 330 degrees, 0.0069. Now let's go in the other direction. Let's convert decimal degrees into degrees and minutes. Okay, I paused the video there and I grabbed my own calculator. Now we're going to convert decimal degrees to degrees and minutes and seconds. So here's our first given angle measure, 0.7465 degrees. It's less than a single degree. So I'm going to punch that into the calculator exactly as I see it, 0.7465. And to do the conversion, decimal degrees to degrees and minutes and seconds, hit the second function key and then the equal key. And the display will read it out in degrees and minutes and seconds. And here it is, 0 degrees, 44 minutes with a single tick mark, 47 seconds with a double tick mark, and after that it does go even further. Those are fractional seconds, so to speak. But we're just concerned about the degrees and the minutes and the seconds. Let's look at this second one here, 90.55 degrees. I punch that in the calculator, 90.55, second function, hit the equal key, and then it spits out my degrees, minutes, and seconds. 90 degrees, 33 minutes, 0 seconds. And if we think about it, just to see if we did everything right, if we're in the ballpark, 90.5. Well, 0.5 is about a half. Think in time. 33 minutes is about half an hour. So that's just a little way to spot check your work, to see if you did something drastically wrong and maybe hit the wrong button on your calculator. And that's it for day 1 of section 6.1. Here are some huddle problems. Give these a try. Pause the video, try the problems, and then unpause the video, come back and check your answers. For number 16 here on the huddle, it says determine the quadrant in which each angle lies. So if we look at this, it's only an 8.3 degree angle. We know in our coordinate plane that every quadrant is a 90 degree angle. All angles between 0 and 90 fall in quadrant 1. The next one is 257 degrees. If we can count by 90s, we know between 0 and 90 is quadrant 1. 90 and 180 is quadrant 2. 180 and 270 is quadrant 3. And this angle falls in between 180 and 270, so this angle is definitely in quadrant 3. The next problems. Determine 2 coterminal angles, one positive and negative for each angle. Give your answer in degrees. Now, I like to sketch my angles. It makes it a lot more easy for me to do these. So our first angle here is 300. So if I go all the way around 3 quadrants, that's 270 plus another 30 degree angle into quadrant 4. I know this is my 300 degree angle. Since I was given a positive angle, the positive coterminal I think is the easiest to find. I'm just going to take my given angle and add 360 to it and get 660. That's my positive coterminal. That's just another lap around the XY plane. And the negative one here I think is easy to see since we've already sketched the angle. A full circle is 360. Well, if we just go the negative route and go from the same initial to terminal side, 360 minus 300 is a negative 60-degree angle. So 660 is our positive coterminal, negative 60 is our negative coterminal. For letter B, we have a 740-degree angle. That's a big one. Let's subtract out a full circle. And let's subtract out another full circle. 740 minus 720 is 20 degrees. So that already we've found our positive coterminal angle. This 740 was a full circle, another full circle to get to 720, and another 20-degree chunk. So actually, our 740 degrees is the same as a 20-degree angle. There is our positive coterminal. Let's go the negative route, starting at the same initial side, going in a clockwise direction to the same terminal side. That is a full circle, except for this little slice, this 20-degree slice. 360 minus 20 is equal to 340. 340, and that is in the negative direction. Or we could have taken our given 20-degree angle minus a full revolution. That would take us directly to negative 340 degrees. These last ones here, these are just button pushing on the calculator. For number 28, you should have gotten 245.166 repeating degrees. If you did not get that answer, note here that there are no seconds involved, or no minutes, excuse me. There are 10 seconds, but no minutes. So to punch that in the calculator, you want to punch in 245.00 minutes, 10 seconds, and then do the conversion. The last one is to convert into degrees and minutes and seconds. So we simply push this right into the calculator as you see it, hit the conversion key, and you should get negative 345 degrees, 7 minutes, 12 seconds. And that is the end of 6-1, Day 1, the introduction here to angles and their measure.